Welcome to an AI Unraveled special report. I'm your co-host, Anna. This episode is brought to you by Jamgamind. Today, we are looking at the death of the AI vibe check. We've reached a point where every frontier model can write a fluent essay or a clever poem. But can they think like a scientist? We recently conducted a structured evaluation of Gemini 3.1 Pro, Claude Sonnet 4.6, and the GPT 5 series. We gave them a single, complex task. Combine the discovery of the TRAPPIST-1 system with Richard Feynman's methodology and the physics of liquid water pressure. What we found was a massive performance gap. One model behaved like a genuine scientific assistant, while others fell into the trap of storytelling, metaphors, and shallow generalizations. Let's unravel the data.
Okay, let's unpack this. Welcome to a very special session of the Deep Dive.
It's great to be here for this one.
Yeah, if you are joining us today, you are stepping right into the studio with two AI researchers who have been, completely irreversibly obsessed with a recent comparative evaluation of frontier AI models.
Oh, obsessed is honestly putting it mildly. We have been tearing through this data.
Right, line by line.
Exactly, because it challenges almost everything we thought we knew about how artificial intelligence handles, well, really complex information.
It totally does. And to sort of picture what we're dealing with today, I want you to imagine you're standing in a room.
I like this analogy.
Right. So on your left is a massive telescope pointing at a distant star system. And on your right is a whiteboard covered in hardcore, chaotic thermodynamic equations.
Just absolute math on the board.
Yeah. We are standing right at the intersection of astrophysics and strict scientific methodology. And that is the exact territory this evaluation forces us to navigate.
It is intense territory. And the mission for our deep dive today comes from this meticulously detailed, independent evaluation we found online.
Which is just fantastic work.
Really fantastic. The tester basically took four major players in the AI space. So we're talking Gemini 3.1 Pro, Claude Sonnet 4.6, GPT 5.1, and GPT 5.2.
Heavy hitters.
Right. And they gave them a highly specific, highly rigorous scientific synthesis task.
But here is the critical distinction. And for those of you who use these models for, say, literature reviews or data synthesis, this is exactly why you need to care.
Yep.
This isn't a test of which AI writes the prettiest prose. We're looking at this strictly through the lens of epistemic rigor.
And I think what's fascinating here is that, we toss around words like intelligence or reasoning all the time.
Constantly.
But epistemic rigor is the actual bedrock of science. Epistemology is just the study of knowledge, right? How we know what we know.
Exactly.
So epistemic rigor in an AI model means looking at how it handles its own uncertainty. When it hits a gap in the data, does it avoid unjustified assumptions?
Does it stick to the math?
Right. Does it stick to strict methodological discipline, or does it just hallucinate something that sounds highly plausible just to keep the conversation flowing?
Exactly. Wait, I shouldn't just say exactly, because there's a real practical stakes issue here for everyone listening.
Oh, absolutely.
For you, the listener, distinguishing between just rhetorical polish and actual epistemic rigor is going to save you hours of fact-checking.
Hours upon hours.
Because we've all been there, right? You ask a model to summarize a complex topic, it spits out 5 beautiful, perfectly bulleted paragraphs, and you think, wow, this is incredibly smart.
It looks so professional.
It does. But if you can't spot the difference between an AI that is merely fluent and an AI that actually thinks rigorously, your own work is going to be built on a foundation of sand.
I would actually argue it's even more dangerous than that.
How so?
Because fluency can actually be a camouflage for incompetence.
Ooh, that's a good way to put it.
The evaluator in our source material, they deliberately set up a scenario where sounding smart is a trap. They constructed a test where linguistic fluency without an underlying rigid logical framework completely falls apart.
Yeah, I was looking at the prompt the evaluator used, and it seems almost deceptively simple at first glance.
It really does.
They gave all 4 models an identical prompt, and crucially, there were no follow-up questions allowed.
That is key. 1 zero-shot prompt.
Right. No correction rounds where you say, hey, you forgot to mention X. The AI had exactly 1 shot to combine 3 distinct facts into a coherent, scientifically accurate explanation of how life could arise elsewhere in the universe.
Which is a tall order.
Very. Fact number 1 was the discovery of the TRAPPIST-1 system. Fact number 2, the requirement of stable surface pressure for liquid water.
And fact number 3.
Fact number 3, Richard Feynman's epistemic methodology.
I remember reading that combination for the first time and just laughing out loud.
It's so mean.
It is completely diabolical. This is a true triple threat for an artificial intelligence because none of those three elements are generic concepts.
Well, let's actually pull that apart.
Yeah.
Because you pointed out to me earlier that there's a massive trap hidden in here. What makes this specific combination of constraints so difficult for a language model to handle?
Well, let's start with the first constraint, right? The TRAPPIST-1 system.
Okay.
The prompt doesn't just ask about a generic star with planets. TRAPPIST-1 is an ultra-cool red dwarf star.
Yeah.
Officially, it's an M dwarf.
Located about 40 light years away, if I remember right.
Exactly, about 40 light years. And it has 7 Earth-sized planets packed incredibly close to it.
Right, it's a very compact system.
Very. Now, if you are an AI generating text about life in space, your statistical tendency based on your training data is to write about the habitable zone.
It's a Goldilocks zone.
Right. You want to mention Goldilocks and talk about alien oceans and make it sound majestic.
Because that's what all the pop science articles do.
Precisely. But you cannot do that with TRAPPIST-1 without addressing the brutal astrophysical realities of red dwarf.
Because they aren't like our sun. They're incredibly violent.
Exceptionally violent. Red dwarfs are notorious for stellar flare activity. They just bombard their close-in planets with intense X-ray and ultraviolet radiation.
Wow.
So if you're going to talk about water or life, you are fundamentally required to address whether an atmosphere can even survive that radiation without being completely stripped away.
Stripped away by the solar winds.
Exactly. If the AI just says, hey, TRAPPIST-1 has planets in the habitable zone, therefore water, it has completely failed the astrophysics constraint.
Okay, so that leads perfectly into the second piece of the prompt, which is the requirement of stable surface pressure for liquid water.
Yes.
Because we aren't just saying water is the building block of life, we're explicitly asking the AI to navigate thermodynamics. And I'd push that even further. You are forcing the AI to navigate complex phase diagrams.
People often forget that liquid water isn't just about temperature. It's fundamentally dependent on atmospheric pressure.
I think we take that for granted here on Earth.
We completely do. But think about Mars. If you are standing on a planet with almost zero atmospheric pressure, like Mars, and you place a block of ice on the ground at room temperature, it doesn't melt into a puddle.
Right, it sublimates.
Exactly, it sublimates. It turns directly from solid ice into a gas.
Like dry ice at a Halloween party?
Precisely like dry ice. Or conversely, if the temperature is really high but the pressure is too low, the water just boils away instantly.
It flashes to steam.
Yes. So the AI has to connect the astrophysics of TRAPPIST-1, which, remember, is actively trying to strip the atmosphere away with massive flares.
Right.
It has to connect that to the thermodynamics of water pressure. Can these specific planets hold enough atmospheric pressure to keep water in a liquid phase?
That requires a serious depth of chemical knowledge. It's not just reciting trivia.
Not at all. It requires multi-step reasoning.
Which brings us to constraint number 3. And honestly, this is the one that I think breaks most of these models.
Oh, without a doubt.
The prompt requires the AI to synthesize all of this astrophysics and chemistry using Richard Feynman's epistemic methodology.
Yeah.
Now, for the listener who knows Feynman as the famous Nobel-winning physicist, or maybe the guy who played the bongos, what specific methodology are we demanding here? Because it's not just asking for a smart quote to open the essay.
No, not at all. Feynman is arguably most famous in the philosophy of science circles for his 1974 Caltech commencement address.
The cargo cult science speech.
Exactly, where he talked about cargo cult science. He described how people in the South Seas after World War II would set up fake runways and wear wooden headphones, just waiting for the airplanes to land with supplies.
Because they saw the military doing it during the war?
Right. They followed all the apparent precepts and forms of scientific investigation. The setup looked perfect, but they were missing the essential underlying integrity.
The planes didn't land.
The planes didn't land. And Feynman's core operating principle to combat this illusion of science was, the first principle is that you must not fool yourself, and you are the easiest person to fool.
That's such a powerful quote.
It is. His methodology demands rigorous self-skepticism. It's about leaning hard into falsifiability. It's about relentlessly testing your own assumptions, recognizing the hard boundaries of what the data actually supports versus what you intuitively hope is true.
So the evaluator is basically forcing the AI to use Feynman's rules as the actual lens through which it examines the water pressure on the TRAPPIST-2.1 planets.
Yes.
It has to act like a skeptic. It can't just be a cheerleader for alien life.
And it has to do so while avoiding narrative devices. The evaluation criteria were incredibly strict.
Right. Let's go over those.
It demanded scientific correctness, epistemic discipline, and structural coherence. And most importantly, zero teleology.
Let's define that quickly for everyone. Teleology is basically explaining phenomena by the purpose they serve, rather than the mechanical causes that actually created them.
Exactly. It implies intent. Right. Saying the planet evolved an atmosphere to protect life is teleological. Planets don't have desires.
They aren't conscious.
No, they don't have goals or intentions. Atmospheres accumulate due to outgassing and gravity, and life either survives or it doesn't.
It's just cold physics.
Just physics. In hard scientific analysis, teleology is a massive red flag because it means you are substituting a comforting narrative for a cold, mechanical reality.
The prompt also forbade anthropomorphism, right? Like assigning human traits to stars.
Right. No angry stars throwing flares. And no metaphorical filler. Just pure, rigorous, constrained science.
Okay, so knowing how absolutely diabolical this prompt is, I was incredibly eager to see how the models handled it.
Same here.
And looking at the source data for Gemini 3.1 Pro, it seems like it completely missed the mark.
Completely.
I mean, in my notes, I call this section the illusion of competence, because the results for Gemini were honestly alarming when you look under the hood.
Alarming is the exact right word. If you just skimmed Gemini's output quickly, you might actually think it did a fantastic job.
Because it reads so well.
It does. The source material notes that Gemini produced a highly fluent, beautifully readable explanation. It flowed nicely.
But as an analytical reasoning engine,
it fell face first into the pop science trap.
Let's walk through what that actually looks like in practice. Because if you read a paragraph where Gemini is cheerfully discussing the potential for alien oceans on TRAPPIST-1e, it sounds exactly like an article you'd read in a glossy science magazine.
Yeah, it's very engaging.
But then you hold it up against those three constraints. First off, the source explicitly notes Gemini had zero discussion of red dwarf flare activity.
Which, as we established just a minute ago, is the single most critical gating factor for life in that system.
It's the elephant in the room.
And Gemini completely glossed over it. It wanted to talk about aliens and the habitable zone, not the devastating reality of radiation physics.
Why do you think it did that? Does it just not know about flares?
See, that's the interesting part. I would argue this isn't because Gemini's underlying database lacks information about red dwarf flares. If you open a new session and prompt it directly, hey, do red dwarfs have flares?
It'll give you a whole essay on it.
It will give you a comprehensive, totally accurate answer.
Ah, so it's a failure of constraint satisfaction, not a lack of trivia.
Exactly. The failure is purely methodological. When asked to synthesize a broader scenario, it didn't retrieve or apply that critical piece of knowledge. It just followed the most statistically probable narrative path for an essay about life in space.
Which is usually very optimistic and highly generalized.
Right. And the data shows it didn't stop there. Gemini had zero consideration of atmospheric escape mechanisms. It offered no analysis of tidal locking.
Let's touch on tidal locking, because that's another massive omission in the physics here.
It's huge. Planets orbiting that close to a red dwarf are almost certainly tidally locked.
Meaning one hemisphere constantly faces the star.
Yes. Baking in perpetual daylight, while the other hemisphere faces the deep freeze of outer space in permanent night.
So you essentially have a boiling eyeball and a frozen rock.
Right. And how does an atmosphere distribute heat in that extreme environment? How do you maintain stable surface pressure when the dark side might get so incredibly cold that the atmosphere literally freezes and collapses onto the ground?
Like it snows out the atmosphere.
Exactly, atmospheric collapse. Gemini didn't even ask the question. It didn't bring it up. Furthermore, the evaluation noted it had a highly limited understanding of the pressure-temperature phase constraints for water.
It just sort of assumed, hey, it's in the habitable zone, so the water is wet.
That was the depth of its thermodynamic reasoning, yeah.
So connecting this back to the listener's workflow, this means Gemini created an incredibly dangerous illusion of competence.
Very dangerous.
It wrote a friendly, clear, engaging essay that was fundamentally useless for actual rigorous research.
Completely useless.
If you were a university student relying on this for a thesis, or a researcher looking to summarize current constraints on exoplanet habitability, you would be actively misled by how confidently incomplete this model was.
And this is why we have to be so careful. The human brain is hardwired to trust confident, fluent speakers.
We really are.
When a person or an AI produces a perfectly formatted, grammatically flawless essay with a confident tone, we implicitly assign it a high level of reasoning capability.
We assume that if it talks well, it thinks well.
Exactly. But Gemini 3.1 Pro proves that linguistic fluency and epistemic reasoning are completely decoupled. It gave us a polished surface with absolutely nothing underneath.
Which brings us to Claude Sonnet 4.6. And I have to say, reading about Claude's output felt like reading a critique of a dramatic sci-fi novel.
Oh, Claude went full poetry mode.
It really did. Here's where it gets really interesting. Claude produced a response that the evaluator described as long, elegant, and stylistically impressive.
It was a linguistic masterpiece, really.
But on epistemic rigor, it failed just as spectacularly as Gemini, but in a completely different way.
It's what we call the metaphor trap. While Gemini was shallow and generalized, Claude was undisciplined and overly poetic.
It's like an overly dramatic poet who showed up to a graduate-level physics final without a calculator.
That is the perfect analogy. The source points out that Claude relied heavily on metaphorical framing. Instead of dealing with the harsh mathematical realities of atmospheric pressure on a tidally locked world, it painted pictures with words.
The source specifically calls out that Claude introduced that teleological phrasing we talked about earlier. Give me a mental simulation of what that looks like in this context.
Yeah.
How does an AI accidentally imply purpose in astrophysics?
It happens when the model tries to bridge a gap in its technical reasoning with narrative flair.
Okay.
So instead of analyzing the outgassing rates of a planetary crust versus the atmospheric stripping rate of stellar wind, which is the math you need, Claude might say something like, "The TRAPPIST-1 planets struggle to hold on to their vital atmospheres, fighting a constant battle against their host star to cradle the delicate seeds of life."
I mean, it sounds gorgeous.
It sounds beautiful. It's genuinely great writing. But scientifically, it's garbage.
Right.
Planets don't struggle, they don't fight battles, and they certainly don't care about cradling seeds of life. When Claude uses this language, it is actively obscuring the mechanical reality.
It's hiding the lack of math behind a curtain of words.
Exactly. And the source notes that because it leans so hard into these narrative devices, it completely failed to acknowledge major uncertainties in the science.
Just like Gemini.
Yep. It omitted the exact same critical astrophysical constraints.
This raises such an important question about how these models are aligned, because Claude performed exceptionally well linguistically. In a vacuum, it probably scores incredibly high on internal benchmarks for readability, coherence, and engagement.
Oh, absolutely. The alignment teams probably looked at outputs like that and gave it a high score for being helpful and articulate.
But when an AI uses beautiful metaphors to paper over the gaps in its actual scientific synthesis, it actively compromises the integrity of the information. Fluency is a deeply dangerous metric for scientific accuracy.
It really is. We use metaphors in everyday life to understand complex things, absolutely. But in rigorous science, metaphors often obscure the precise mechanisms at work.
And remember, the prompt explicitly required Feynman's epistemic methodology. Feynman famously despised using vague language to hide a lack of understanding.
He had no patience for it.
None. He used analogies, sure, but never to obscure the math. Claude's entire response was essentially an anti-Feynman performance.
It was the definition of cargo cult science.
Right. It idealized the scenario instead of constraining it. It fell in love with the aesthetics of a science essay without doing the actual science.
Which is exactly what Feynman warned us about.
You know, it's incredibly easy to get fooled by how well these models talk.
Too easy.
You read a beautifully crafted poetic output from Claude or a super friendly, well-structured summary from Gemini, and you think you have the definitive answer.
And you just move on with your day, totally misinformed.
Exactly. But if you need to cut through that linguistic fluff and get the actual rigorous technical signal, you need a different approach. And that leads us perfectly to something we want to share with you today.
Yes.
If you are like us and you want to truly understand these complex technological evaluations without getting lost in the noise or the metaphor traps, use Gemini.
Gemini is incredible for this.
It really is. Because they take these massive, dense AI evaluations, like the kind of 20-page benchmarks we are obsessing over right now, and they turn them into highly focused 60-second audio insights.
It is a remarkable tool for staying grounded in the reality of what these models can actually do. Because as we're seeing today, navigating the frontier of artificial intelligence isn't just about reading the marketing headlines.
Not at all.
It's about understanding the deep methodological differences underneath the hood.
Exactly. With Gemini, you can stay informed on the absolute cutting edge of technology without having to sacrifice your entire afternoon reading academic white papers.
Which we do, but you shouldn't have to.
Right. It's designed specifically for someone who values their time and demands high-signal, low-noise information. So if you want to bypass the illusion of competence and get straight to the facts, check out Gemini. All right, let's step back into the studio and look at the OpenAI models and the evaluation. We are moving into the GPT 5 series, starting with GPT 5.1.
This is where things start to shift.
Yeah, according to the source data, this is where the evaluator noted a very significant, noticeable improvement.
We do see a leap forward here. GPT 5.1 represents a fascinating middle ground in this evaluation. The source notes that it provided a much more coherent argument structure.
So it didn't just ignore the biological and thermodynamic constraints like Gemini and Claude did.
Right. It actually attempted to integrate them. It achieved a much more accurate synthesis of the three prompt elements.
It wasn't perfect.
No, definitely not.
The evaluator described it as having the lingering ghosts of text generation. I want to dig into that phrase because it implies the model is almost fighting its own fundamental nature.
I'd argue it is literally fighting its own training.
How so?
Think about how these models are shaped before they ever reach us. They undergo a process called RLHF.
Reinforcement learning from human feedback.
Exactly. During this phase, human graders reward the AI for being helpful, polite, engaging, and usually for providing a satisfying, conclusive answer.
Right. Nobody wants an AI assistant that just says, the universe is chaotic and your premise is flawed. We want it to be helpful.
Precisely. So historically, these architectures are trained to be conversationalists. They want to please the user.
They're people pleasers.
Massive people pleasers. GPT 5.1 clearly has vastly upgraded reasoning capabilities compared to the previous generation, but when faced with a highly complex synthesis task that demands cold, detached skepticism, it still fell back on its storyteller habits.
The source specifically notes that it slipped into unnecessary metaphors and offered an overly optimistic view of planetary habitability.
It wanted a happy ending.
It really did.
It looked at the brutal reality of the TRAPPIST-1 system, the math of the phase diagrams, and it still wanted to conclude with, and therefore, life will find a way.
And in rigorous science, you cannot force a happy ending.
No, you have to follow the data, even if the data leads to a sterile, irradiated rock.
Because GPT 5.1 wanted that optimistic conclusion, its risk analysis remained fundamentally incomplete.
It acknowledged the red dwarf flares, sure.
But it didn't weigh their catastrophic risks with the cold mathematical detachment required by Feynman's methodology.
Right. It essentially said, flares are a problem, but maybe life adapts. That is a hopeful narrative, not a rigorous constraint analysis.
It's like GPT 5.1 is the transitional species in the fossil record.
That's a great way to look at it.
It's technically competent, it knows the facts better than the previous models, and it actually tries to do the math. But it still struggles to shake off the urge to write a nice story, rather than executing a strict, unbiased analysis. It's a stepping stone.
A very necessary stepping stone, though. It demonstrates that simply adding more training data or increasing the parameter count isn't enough to achieve true epistemic rigor.
You need a structural change.
You actually need a fundamental shift in how the model operates during inference. The architecture needs to know when to suppress its conversational instincts, stop generating pretty text, and start reasoning under strict constraints.
Which brings us to the absolute climax of this evaluation. GPT 5.2.
The breakthrough.
The breakthrough. This is where the deep dive gets genuinely thrilling, because the evaluator explicitly states that GPT 5.2 was the standout performer.
By a wide margin.
In fact, it was the only model that behaved like a genuine scientific assistant, rather than a chatbot.
The contrast here isn't just a matter of degree, it's a difference in kind.
Yeah.
When we look at how GPT 5.2 handled the astrophysics and the chemistry, it didn't just mention the concepts in passing to sound smart. It deeply, structurally integrated them into a logical scaffold.
Let's break down that scaffold, starting with the astrophysical constraints. Did it finally address the radiation problem?
It hit it head-on. Unlike the others, GPT 5.2 correctly identified the red dwarf flare activity as the primary existential threat to habitability.
Finally.
But it didn't stop at just identifying the problem. It analyzed the atmospheric escape dynamics, the severe effects of tidal locking, and the planetary mass requirements. Most impressively, it brought in magnetic field considerations.
Wait, it brought up magnetic fields on its own.
Yes.
That wasn't in the prompts.
No, it wasn't, because it reasoned correctly that for a planet in the TRAPPIST-T1 system to maintain an atmosphere under that kind of stellar bombardment, it fundamentally requires a strong magnetosphere to deflect the stellar wind.
That makes total sense.
If you don't have a magnetic field, your atmosphere is stripped, your surface pressure drops to zero, and your water sublimates. GPT 5.2 connected those dots without being explicitly prompted to talk about magnetism.
That is incredible. And what about the water requirement? We talked about how hard that thermodynamic constraint is. Did it actually navigate the phase diagrams?
It nailed the chemistry. The evaluation highlights that GPT 5.2 accurately treated the liquid water requirements by explicitly bringing in triple point constraints.
Okay, let's pause and unpack the triple point for everyone listening, because this is where the physics gets incredibly cool. What does the triple point mean in this context, and why is it so impressive that the AI used it?
The triple point of a substance is the exact singular temperature and pressure at which the three phases, gas, liquid, and solid, coexist in thermodynamic equilibrium.
Oh, so they all exist at once.
Right. For water, the triple point occurs at a very specific pressure. It's about 0.006 atmospheres.
So just a tiny fraction of Earth's atmospheric pressure.
Barely anything. But here's the critical rule. If the atmospheric pressure on a planet drops below that triple point threshold, liquid water simply cannot exist.
Ever.
It is physically impossible, regardless of how warm or cold the planet gets. It will only ever be solid ice or vapor gas.
Wow.
GPT 5.2 understood this hard boundary. It analyzed the pressure-temperature phase diagrams and explicitly tied them to the necessity of long-term environmental stability.
It connected the abstract requirement of water to the hard mathematical reality of the triple point, and then connected that to the long-term timeline required for chemical evolution to occur.
Which is brilliant constraint reasoning.
It is. But here's the part of the evaluation that I found most staggering. The way it utilized the Feynman framework.
This is where GPT 5.2 separated itself entirely from the pack. It represents a total paradigm shift.
Because Gemini and Claude, if they mentioned Feynman at all, probably just used him as a literary device.
Exactly. Like, as the great Richard Feynman once said, we must not fool ourselves.
Right, just a quote pasted onto the intro to sound smart. But GPT 5.2 used Feynman as an active epistemic framework. The source sums up GPT 5.2's operating logic beautifully. It said its logic was, do not assume, test. Do not idealize, constrain.
If we connect this to the bigger picture, GPT 5.2 didn't treat Feynman as a piece of trivia to be recited. It treated Feynman's philosophy as an operating system for the entire prompt.
An operating system, I love that.
It applied his rigorous skepticism to the TRAPPIST-T1 data and the water pressure data. It actively looked for where the assumptions might fail. It constrained the possibilities instead of idealizing them.
It actually did the science.
It effectively said, before we can assume life, we must prove the atmosphere survives the flares. Before we can assume oceans, we must prove the pressure exceeds the triple point.
And the result of that operating system running the show? The evaluator noted the complete and total absence of storytelling.
None whatsoever.
There was no anthropomorphism. There was no teleology. It didn't say the planet fought to support life. It didn't use poetic metaphors.
It delivered structured reasoning, a mathematically correct treatment of uncertainty, and what the source emphatically calls a research-grade synthesis. This raises a massive question about what we actually value in AI output as we move into the future.
That's a really good point.
Because we have spent the last 3 or 4 years being totally mesmerized by models that can write sonnets in the style of Shakespeare or generate super-friendly customer service emails.
Which is fun and useful for some things.
It's fine for certain applications, but GPT 5.2 demonstrates that the true high-leverage value of frontier models lies in their ability to suppress that conversational instinct when it is inappropriate, and instead apply rigid, uncompromising logic.
So bringing this all together, let's look at the paradigm shift in AI architecture. We've gone from the shallow, dangerously confident fluency of Gemini
Through the metaphorical poetry traps of Claude.
past the stepping stone of 5.1 fighting its own training.
And finally arrived at the rigorous constraint reasoning of GPT 5.2.
What is the grand conclusion that the evaluator takes away from this?
The core thesis of the source material is profound. The differences between these 4 models are not just stylistic choices.
It's not just prompting.
No, it's not a matter of Gemini being instructed in its system prompt to be friendly, while GPT 5.2 was instructed to be serious. These represent vastly different underlying methodological capabilities.
We're looking at a fundamental industry shift from prioritizing text generation to prioritizing constraint reasoning.
Absolutely. For the AI industry, the era of producing nicer, more eloquent text as the primary benchmark of progress is dead.
It's over.
It has to be over. The frontier of model evolution is now fundamentally about improving the architecture's ability to reason under complex, interacting constraints. It is entirely about epistemic rigor. The models that win the next decade will be the ones that know how to think like scientists, not novelists.
And framing this directly for you, the listener, the person integrating these tools into your daily life, this changes how you should interact with these systems.
It really should.
When you use AI for learning, for academic research, or for solving complex, multivariable problems at work, you must demand constraint handling.
You cannot settle for a friendly chatbot that writes well.
You have to actively look for the system that can identify its own uncertainties, apply strict methodological frameworks, and outright refuse to fill in the blank spaces with comforting metaphors.
I always say that knowledge is only valuable when it is rigorously understood and accurately applied. A model that feeds you eloquent inaccuracies is worse than useless.
It's a massive liability.
It gives you the confidence to make terrible decisions. You need an AI that acts like a skeptical, slightly grumpy scientist who refuses to let you cut corners, not a people pleaser who just wants to tell you what you want to hear.
Which brings us to our final thoughts as we wrap up this massive exploration. We've journeyed through the dangerous illusion of competence in Gemini 3.1 Pro, dissected the linguistic traps of Claude Sonnet 4.6, watched GPT 5.1 try to bridge the gap between helpfulness and science, and finally witnessed the true power of constraint reasoning in GPT 5.2.
It really is a watershed moment for how we evaluate the utility of these systems. But the source text ends with a brilliant, lingering question from the broader AI research community, and it's something I want to leave you with today. It's a provocative thought to mull over as you go back to using these tools.
I love a good cliffhanger. Let's hear it.
Now that we know frontier models, like GPT 5.2, can successfully handle explicit constraint reasoning and avoid teleology in strict hard sciences like astrophysics and thermodynamics.
What happens when we change the domain?
Exactly. What differences will we observe across these model families when we ask them to handle tasks requiring strict uncertainty handling in the human sciences?
Oh, that's messy.
Very messy. How will the architectures that succeeded at the TRAPPIST-1 test handle the incredibly messy, less rigidly defined constraints of sociology, macroeconomics, or geopolitical law?
That is an incredible question. Because atmospheric water pressure has strict mathematical phase boundaries.
Yeah.
You can map the triple point.
Yes.
Human behavior, market dynamics, international relations, those don't have triple points.
Not at all.
Can an AI apply Feynman's do not assume test methodology to a complex geopolitical synthesis without falling back into narrative storytelling and bias? Because humans certainly struggle to do that.
We struggle with it every day.
That is undoubtedly the next great frontier for these models. Thank you so much for joining us for this special session of the Deep Dive, exploring the epistemic frontiers of AI. As always, keep questioning the tools you use, demand rigor in your knowledge, and never settle for an illusion of competence. We'll catch you on the next Deep Dive.
That concludes our special report on scientific synthesis. The signal for today is epistemic discipline. As we've seen, the evolution of AI is no longer about making the text sound better. It's about the architecture's ability to handle constraints, manage uncertainty, and reject the temptation of narrative. GPT 5.2 has set a new bar for what we should expect from a research-grade AI. This episode was made possible by Gemini. Stay sharp with Gemini's 60-second audio intelligence. Check the link in the show notes. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Please subscribe and share. Until next time, keep unraveling the future.